In this problem, we're asked to solve this equation here. Now notice, there are 3 terms in this equation. Each term is log to the base 2 of a quantity. So in log equations, if every single term is a logarithm, we would like to use the one-to-one property of logarithms. And what this property says is, if log to the base b of u equals log to the base b of v, then u has to equal v. So what we want to do is get 1 log on the left-hand side, 1 log on the right-hand side. Each of the logs has a coefficient of 1. If that is true, then the arguments of the 2 logs have to be equal. Looking at our equation, we can see that we have 1 log on the right-hand side. It has a coefficient of 1, but I have 2 logs on the left-hand side. So we have to use our properties of logs that allow us to combine logarithms. And remember, if we have log to the base b of m divided by n, it's log to the base b of the numerator minus log to the base b of the term in the denominator. So this is my positive log. It's going to, x minus 1 is going to go in the numerator. Since I have minus log to the base 2 of x plus 3, my x plus 3 has to go in the denominator. So my left-hand side is going to become log to the base 2 of the quantity x minus 1 over x plus 3 equals log to the base 2 of 1 over x. Now I have 1 log here, 1 log here. They each have a coefficient of 1 in front of them, so I can then set these 2 arguments equal. So now I know that using the one-to-one property, x minus 1 over x plus 3 has to equal 1 over x. So now I have a rational equation. And what I can do to get rid of my denominators is I can find the least common denominator, which is just going to be x plus 3 times x. And you can multiply both sides by the LCD. Don't do it in your head. Actually write it out. The x plus 3 is reduced here. The x is reduced here. And I get left with x times x minus 1 equals 1 times x plus 3. So now I need to simplify by distributing in my x. X times x is x squared. X times negative 1 is negative x. Equals, and on my right-hand side, 1 times x plus 3 is x plus 3. So what type of equation do I have now? It's degree 2, it's quadratic, so let's get everything on one side. So I'm going to subtract x from both sides, and I'm going to subtract 3 from both sides. And so I'm going to get x squared. Negative x minus x is negative 2x minus 3 equals 0. So there is my quadratic equation, and I think this one is fairly simple. It's going to factor. 2 things multiply to x squared. I need an x and an x. Now I need 2 numbers that multiply to negative 3 and add to negative 2. So I think my numbers are 3 and 1, and since they have to add to negative 2, it's negative 3 plus 1. And don't forget, you can always FOIL it back out to check. X times x, x squared, plus x from the outer term, minus 3x from the inner term, minus 2x, and minus 3 from the last term. So now two factors multiplied together equal 0. Set each of them equal to 0. And solve each of those equations. So I'm going to get x equals 3 and x equals -1. However, we are not done yet. These are only potential solutions. We have to check them in the original equation because they might be extraneous. So let's go to the next slide. So here are the potential solutions I got on the previous slide. So now what I have to do is I need to check both solutions in this equation. That means I need to plug in the value of x in these three places and see if the arguments are positive or negative, because I can only take the log of a positive number. So let's check x equals 3. So I'm going to have log to the base 2 of 3 minus 1. Well, 3 minus 1 is 2. Is 2 a positive number? Yes, I'm happy with that part. Next part, minus log to the base 2 of, I'm plugging an x in here now, of 3. So I'm going to have 3 plus 3. And what is 3 plus 3? That is 6. It's positive, still happy. Equals log to the base 2 of my quantity 1 over x, which is 3. And is 1/3 a positive number? Yes. So each of these arguments here, here, and here, I have a positive number. Therefore, I know that x equals 3 is not an extraneous solution. So we're checking for extraneous solutions. Now I need to check when x equals -1, my other solution. So log to the base 2 of -1 minus 1. Well, -1 minus 1 is -2. It's not possible to take the log of a negative number. That means x equals -1 is an extraneous solution. So this equation only has one solution, and that is x equals 3. One last comment is I want you to note that directly I found the first argument of a log was negative. I didn't have to bother checking the rest of the equation. Directly I got to this point, I knew that x equals -1 was extraneous.